In this video, we are going to solve another application about the speed, the average speed, instantaneous speeds, and so on. So consider an inclined airtable and two pucks A and B. Puck A is released from rest down the airtable, while puck B is launched up this table with initial velocity vector v naught vector of magnitude v0 and parallel to the table. The time constant is tau equal 100 milliseconds, so the time separating two successive positions is 100 milliseconds. Registrations of puck A are recorded. This is a table showing position A0, A1, A2, A3 till A6, and instance T0, tau, 2 tau, so this is T1, T2, T3, T4, and so on. And given the distances between two successive positions xi, so it's called A0, AI, so if I is 1, then this is x1, it's the distance from A0, and so on. So now studying the motion of puck A, specify the trajectory described by the puck A. Specify means you have to justify your answer. So the trajectory described by the puck is rectilinear since the dots are collinear. So upon joining A0, A1, A2 till A6, we obtain a straight line. So that's why it's a rectilinear pathway or rectilinear trajectory. Part 2, calculate the instantaneous speeds at A1, A3, and A5. So V1 is equal to A0, A2, A0, A2. So it is 5 centimeter times 10 power minus 2 to convert it to meters over 2 tau. So we have from A0 to A2, it is 2 tau. So 2 times 100 milliseconds multiplied by 10 power minus 3 to convert it to seconds equals 0.25 meters per second. V3 is, we'll consider the position before and after. So the distance from A2 to A4 over 2 tau, it is A2 to A4 is actually equal to A0, A4 minus A0, A2. So we get the distance A2, A4. Okay, so that's why we wrote 20 minus 5 times 10 power minus 2 over 2 times 100 times 10 power minus 3 is equal to 0.75 meter per second. Now V5, also for V5, if you want to explain it clearly, it's equal actually to A4, A6, so it's actually equal to A0, A4, and here we have A0, A6. So if we take A0, A6 minus A0, A4, we obtain the distance A4, A6. So it's the difference between them. We are given the distances here. This is A0, A1. This is A0, A2. This is A0, A3. This is A0, A4. This is A0, A5. A0, A6. So if you want A4, A6, we have to subtract A0, A6 minus A0, A4. So we get the difference between them, which is A4, A6. So it's 45 minus 20. 45 minus 20 times 10 power minus 2 to convert it to the SI unit over 2 tau, we obtain 1.25 meter per second. Now represent the velocity vector of the puck A at A1 using a convenient scale. Represent the velocity vector. This means that we should have the instantaneous speed at this instant or at this position, and we should know the direction. So we are given that we calculated it and found it to be 0.25 meter per second. If you take the scale 1 centimeter, 0.25 meter per second, and you do cross multiplication, if you say 1 centimeter is 0.25 meter per second, and it's already 0.25 meter per second, then the length of the vector is going to be 1 centimeter. If you take another scale, for example, every 1 centimeter is equal to 0. For example, 1 meter per second, then 0.25 meters per second is how long? Okay, is how long? You do the cross multiplication. If find it that 0.25 times 1 centimeter over 0.1 meter per second is going to be 2.5 centimeter. So you draw starting from A1 2.5 centimeter to the right. How did we know that it is moving to the right? It's represented in the given. Now, part 4 of the same question, calculate the acceleration at A2 and A4. This means that they want the instantaneous acceleration, then deduce the nature of the motion of block A. At A2, this means we need V3 before, after minus before. So V3 minus V1 over 2 tau. These are already calculated in the previous part. Over 2 tau because from A1 to A3 there are 2 tau. So 2.5 meter per second squared, and similarly for A4 we need V5 after minus V4. So V5 minus V3 is equal to 2 tau, and we obtain the same value. So now concerning deduce the nature of motion, comparing the accelerations at different instants, they are equal. So this means that the motion is rectilinear because already we said that the trajectory is a straight line, and accelerated with constant acceleration. We call it uniformly accelerated rectilinear motion, abbreviated by UARM. And finally, represent the acceleration vector at A4 using a convenient scale. Now, because the obtained acceleration is positive, so it is going to be in the positive sense of the x-axis. So the vector representing the acceleration is in the positive sense of the x-axis, as you can see, and taking the scale 1 centimeter 2.5 meter per second squared, and it's already equal to 2.5 meter per second squared. Then this means that the length of the vector is 1 centimeter. So you have to draw the line, show the arrow, and write the A4, the name of the vector.